The last thing that we want when we launch our software product is that this happens. And the biggest cause of system failure is not handling your errors correctly. And that causes the program to crash. So in this one, I'm going to show you how to handle your errors so your program doesn't crash but continues to operate normally. So here we can see this weird block. Try, except, else, and finally. This is a control block for catching errors in Python. It basically means try something, if it fails do this, otherwise do this, and finally always do this. Now you haven't seen the pass keyword before in Python, but if we hover over it, it's going to tell us that it's a null operation. It basically does nothing. So now we've got to fill this in. So let us write a program that simulates user input. So I got user input number and user input divisor, and we're going to divide this by this. If we run this, we will get a divide by 0 error. And you can see here, 0 division error, division by 0, which isn't allowed because it's actually infinity and computers can't handle that. Okay, so how do we deal with this? Well, as I said, let's try it. So we move this here into our try. So we're going to try to do this. If it fails, let's print cannot divide by 0. And if we run this code now, you'll see we get cannot divide by 0. Now, if the user didn't enter 0 and entered actually a number, we want to print the results. We can do this in the else block. And then change our divisor to 2, we should get 50 printed. And we do. All good so far. Now, you might be asking, why don't you just put your print result up here? So if we put that pass there, and then up here, we can do print result. The problem here is the moment it hits this line, it's going to go straight into the exception block. So that's never going to execute if there is an error. Now, you might also ask, why don't you put it after your try and except block? And we can absolutely do that, but now we get a different error. Result is not defined, and that's because this line never ran, so result was never created. So in general, else is a really good way to handle what you want to do on success of a try. Now, you can always work around that if you absolutely want to, so we could do result equals 0, but now when we run it, we get cannot divide by 0 and 0. The problem with the 0 here is it doesn't accurately depict what the result should be. So in general, put it in the else block. Now what happens if a user enters something a bit weird like cat? Divide by cat is a perfectly normal operation, I'm sure. The problem is now we're getting cannot divide by 0, and we didn't. So how do we handle this? Let us take our exception here. And I happen to know that the exception that we catch for 0 is 0 division error, and now we get an error, because it's tried to catch 0 division, but that didn't happen, so it's actually errored out. You'll see here we got a type error, unsupported operand type for int and string. What we can do is add a second except block to catch type error, and we can print both entries must be numbers. And now when we run the code, you'll see both entries must be numbers, and if I put this back to 0, you'll see that we get cannot divide by 0. So basically, it runs through each except block, checks to see if it's that error, and then will throw the error. Now, there are situations where you want to know what the actual error message was that came from the code. And the way we can capture that, if we go to our except here and do as ERR, what this does is it copies the error message into ERR. And if we change this to a dash, put in some squiggly brackets and do an F, we can print the actual error message along with our nice error message. So if we run this now, there you go. Cannot divide by 0, division by 0. And we could do the same here if we wanted as well. Now you may be tempted just to catch except exception, and we can actually do that, but I would advise against it. But something I do want to show you is if we do except exception here, and let's do print something unexpected happened. Now when we run our code, even though it's a divide by 0 error, it's actually going to tell us that something unexpected happened. And that's because the code will fall into the first exception that matches. And as all exceptions are derived from exception, then this will catch everything. So if you are going to capture except exception for any reason, always put it at the end. I may say if we get any other exception, we're going to put 0 in because we're going to ignore the user input. It will work. And to just prove this, I'm actually going to cause an error in our code deliberately using something called raise. What raise does is says raise this exception. So what have we got? Let's do an environment error. And let's say service is down. Now what this will do is it will run the first line of code If it errors, it'll come into here. If it succeeds, it's going to cause an error. So let's put this back to 2. And normally here we'd expect it to result 50, but it's not going to. And you'll notice something weird. The code actually succeeded, but nothing was printed, which is a bit odd. And that's why I like to avoid exception. Because we've raised an environment error, we weren't expecting it. And so the program has silently hidden the error. If we go on later to use result to do another calculation, say we're doing an exchange rate on a currency, we get a currency, we times it by 0. The problem is we're going to give somebody something for free. So do avoid things like this. If you don't expect an error to occur, then don't catch it. Let the program fail, because then your QAs can pick it up, or you can pick it up when you're unit testing, and you can actually put in a proper exception code. And if our service is down, there's an argument to say that our program should just go, I'm sorry, I can't operate, and it should crash. So we could actually just change this to service is down, aborting process. And this is perfectly justified. If we now take out our accept exception and run it again, you'll now see environment error, service is down, aborting process. That is a perfectly good reason to stop a program. It's not something we can control, and so we have to stop. Anyway, I'll get off my soapbox now. I hope that's pushed how much I hate exception anything, do nothing. It's bad. We've talked about try, except, and else. What does finally do we think? It runs regardless of what happened. I could just put this ran here. Now you may be thinking, what the hell is the point of that? And you don't actually have to use it, and you don't actually have to use an else. So I can comment both of these out, and the code will work fine. But I do suggest you use the else where you can, because it only runs it if it succeeded. And you want to keep your tries pretty small so that you know exactly what you're catching. Normally the reason for using finally is for clearing up resources. So you might want to print service connection close. And in the real life, we might call database.close or file.close. Basically, I've used some resources in doing what I'm doing. I want to clear them up because I don't want to leave them open for the rest of my program to run. Finally should always be used for cleaning up things that you want to clean up before you exit this piece of code. I hope you found this video useful. If you have, then please consider subscribing. It helps me out a lot. In our next video, we're going to talk about something really important, and that is how to handle files. And most programs don't do an awful lot unless they have a file behind them or a database or something, but a database is just a collection of files. So it's something absolutely essential that you're going to use at some point in your career. If you're watching this video a little late, then that video will be top left right now. And as always, thank you for watching, and I hope to catch you on the next one.